All right, so today we need to finish up talking about section 5.4, at least getting all the information learned from 5.4. We might practice a little bit more of it next week. But we've got essentially one vocabulary word. It's going to take a little bit of time to kind of break down what that vocabulary word means to us, how we can see it in a picture, all that kind of stuff. But an altitude is the perpendicular segment from a vertex of a triangle to the line containing the opposite side. Okay? You're seeing questions in your homework that ask you to identify, is this a median? Is this a perpendicular bisector? Is it a altitude? Is it an angle bisector? Okay? And the only way that you can actually answer those is if you know all four vocabulary words, right? You got to look at your segment that they're providing you and say, okay, it's starting at a vertex, and it's going perpendicular to the other side. Oh, that means it met the definition of an altitude, right? Or if it's starting at a vertex and it's now going to the median of the other side, the midpoint of the other side, then that meets the definition of being a median, right? What if it starts at a vertex, it goes to the midpoint of the opposite side, and it's perpendicular to the opposite side? It's both, okay? So you look at your segment and say, okay, what criteria is being met by this segment? Do I have perpendicular? Do I go to a midpoint? All right? That type of information then is going to be able to allow you to address, okay, what vocabulary word does it meet? Okay? If I've got 4 vocabulary words, freshman, sophomore, junior, senior, okay, and then I have a list of criteria that allows you to be classified in one of those categories, and I want to look at, let's say, Canyon, and I want to say I want to put in one of those categories. I look at his credits, say he's got more than 21 credits, he's a sophomore, right? Got less than 20 credits, he's a freshman, or whatever. I don't even know how many it is, but it's probably not that. Okay, 5. So 20 is the total, right? 20, something like that. What? Well, if you're a diligent student, you could have 21 in a year. I did. Huh? Are you? All right, so what we need to understand is that, we see a picture of this, altitudes of triangles can be on the inside, they can be on the outside, or in right triangles, they're actually the sides of your triangle. Okay, or 2 of them are. This is a very, 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 very important phrase right here. Here. I don't know what that's all about. Hold on. All right. So the line containing the opposite side. We need to realize that it's not just the opposite side, because there will be situations where there will never be, if I just look at the opposite side of a triangle, there will never be a line from my vertex perpendicular to it. I'll give you that example here quickly in a moment. Okay?
What's it called, like you get like so high in the air? What's that called?
Your altitude. Yep. A little bit. So Keenan's question is, so if I'm on an airplane, they talk about the altitude of the airplane, right? Okay, they talk about the height that the airplane is off the ground, correct? Okay. Now this is important to understand, and this is something that I think mathematically people get into trouble with a little bit, is because we have kind of fields of study, right? We have fields of aeronautics, we have fields of geometry, fields of algebra, fields of science, that we do all this studying and analyzing of things, okay? But within those fields, we like to use the same types of words. And if you just think about everyday vocabulary that you use outside of education, okay, you might at some point use the word altitude. Okay, does it carry the exact same meaning outside of math that it does inside of math? Probably not. Okay, does that make sense to everybody? Okay, but there might be a link. Okay, so we're talking about the altitude of an airplane. Kind of think about it this way. If I give you, let's go here. So the altitude of an airplane is based off of sea level. Okay? So sea level is like 0 degrees. Does that make sense? Or 0 feet. Okay? And then if my airplane is maybe, let's say, that point right there. Okay? How many lines go through C that are perpendicular to the ground down here? Just one. Okay? Just one of them is going to be perpendicular, right? That's the one. Okay? So that distance is what your pilot would say if we're cruising at 30,000 feet or something like that. Does that make sense? Okay? Now let's see how that relates to a triangle. If I take that distance, let's make it red, and then I do this. Oh, go back and do it. Is that red distance still the altitude of the airplane? Okay. But now because I put everything in together in a triangle, that is an altitude of our triangle because it meets the definition. It started at C, at vertex, and now we've gone perpendicular to the side or the line containing the opposite side. So that's a link between that field of study or that vocabulary outside of math and the vocabulary inside of math. However, if I look at the definition inside math, it says from a vertex perpendicular to the opposite side. This give me a moment. Okay, that blue ray is also in geometry an altitude. Okay, because it's perpendicular to CB over there at E. Does that make sense? Okay. Now inside aeronautics, am I going to call that a height? No. Okay. That's where we kind of get ourselves into trouble is because an altitude, the way we think about it in an airplane, is different than the altitude that we think about just in general in a triangle. Yes?
There's only 3 altitudes.
Yes, so every triangle is going to have 3 altitudes, okay? And they're going to be what to one another? They're going to meet in the same place. What's that word? Concurrent. Okay. Now, are they equal? That was a question. That was a phrase I heard. So let me take this segment here. So this is, need that intersection point. So that and that. All right. So if I find these distances, A to E, okay, now that is when we go back to, because we'll come back to this stuff later on in like chapter 10 and 11, that could be a number that I use in my area formulas for the area of a triangle, 1/2 BH, right? I could use that blue dotted line, AE, that segment, as an H. But that's going to dictate then to me what I have to use as my base. The base then would be C to B. The base is always the side of your triangle that your altitude is being drawn to. This altitude is 7. That altitude is 6.59, right? Okay. Just to prove a point to you. Now I know there's a lot of junk in here, so it's going to be kind of messy. But I want to talk about how. So that is that side. C, B is that side. BF was that purple one. AB is this one. If I just do some quick math here, okay, with these numbers. All right, so let's say that I said, and let's do some Desmos real quick. So So what's the formula for finding the area of a triangle? 1/2 BH. So if I go 0.5 times a base times a height, I should get my area of my triangle, right? So let's use so AE was one of my bases, right? So one of my altitudes, right? One of my H's. So let's use 9.62. So that's talking about H being this blue dotted altitude, okay? The base it goes to is C to B, which is 7.28. And again, area, and if you can see that, it said 35.0168, okay? Now, if I did 0.5 times a different H. So this red one is a different H, right? So CD could be 7. What is the base that CD is going to? It's at 10, right? If I hit enter, it should give me the exact same thing as this one did, okay? Now, you're seeing a little bit different value, right? We're off by 1/100th. And the reason we're off by 1/100th is because there's some rounding being involved with GeoGebra's picture there, okay? Maybe it's probably not exactly 7.28, okay? If I did the other one, let's see how accurate the other one is. So we do 0.5 times, okay, so now the other base would be A to C, which would be 10.63. And the altitude there that we're talking about is BF, which is 6.59. Okay, and again, we're getting pretty close to that number right there. But if we had a better rounding of the 10.63 to 6.59, all those areas would be identical. Does that make sense to everybody? So and why does that happen? Why is this situation occurring, and why can we do it this way? It's based off what we use as an H in our formula. H is not height in our formula. You may have learned that in 7th grade, 6th grade, or whatever, because they never introduced what the word altitude was, but H represents an altitude length, okay? So when I'm working inside this triangle stuff, if we've got this triangle right there, okay, can you guys visualize if you have this triangle like this like this cut out right here, okay? If you had this in your hand or any triangle that's like this piece of plexiglass, and I asked you to put this on your desk, so it's like this on your desk, and you got one of the points on or up in the air, right? Could you take your tape measure from that point straight down to your desk and know the height of that? Okay? Well, that's if you put your triangle on your desk that way, right? Could somebody have done it this way? Is that going to be a different height?
Yep.
Is it going to a different base that's on your desk?
Yep.
Okay, so as those heights and bases change, those values, those numbers are going to change, but their products are going to be the same. So here's the idea. If I look at this one here, the argument is that this distance right here is probably my H, right? Does that make sense? That's if somebody obviously put that triangle on their desk that way. But if I put my triangle on my desk, maybe with that segment on my desk, let me clean that up a little bit, like that, now would you say that the altitude is that distance? Okay? Is that distance obviously different than that one? Yeah, but look at this one's base. That one's base is the black segment. This one's base is the red one. Is the red one bigger? Yeah, okay? So as this one got smaller over here, the base got bigger. So those two values in my product of B and H, as one gets smaller, the other one gets bigger, but the product stays the same, okay? Could I have also taken that triangle and done this and laid it that way on my desk? Is that a third altitude? That makes sense to everybody? So if I draw in all my altitudes at one time, the picture is going to look like this. Something similar to that. Okay? Those are your 3 altitudes of a triangle. Each one of those purple rays starts at a vertex and goes perpendicular to the opposite side, right? Okay? Each one of those is an altitude. Those lines are concurrent at one particular point right there, and it's called an orthocenter. Okay? Now, the way I remember this is, now I've seen this word before, maybe it's the first time you've seen it, is the word orthogonal, okay? Right now, really the only thing you need to know is orthogonal. We can say that that's kind of a synonym for perpendicular, okay? Means the same thing for us as perpendicular. A lot of times, orthogonal is more about lines being perpendicular to planes, planes being perpendicular to planes, that kind of thing. Think about going to the orthodontist. What's the orthodontist do? Huh? Makes you wear braces, but what's the purpose of those braces? Straighten your teeth. Basically to make the gaps between your teeth all parallel, right? If the gaps between my teeth are all parallel, okay, doesn't that mean my teeth are going to be perpendicular to my gums? Okay, so an orthodontist makes my teeth perpendicular or orthogonal to the plane of my gums. Anybody ever had surgery on bones? Anybody ever been to an orthopedic surgeon? Okay, orthopedic, ortho meaning orthogonal. An orthopedic surgeon is going to take the axis that goes through your body from the top of your head through the bottom of your feet. Okay, your axis of like rotation or whatever, and it's going to make sure that is, or try to, the best they can, make sure that line is always perpendicular to the plane that you're walking on, right? So that means that they're trying to keep your body orthogonal to the ground. So orthopedic surgeon. And whenever you see ortho as a prefix, it's talking about some aspect of being perpendicular.
Is there a difference between the point of concurrency and orthocenter?
The point of concurrency, so when lines are concurrent, you get at that point is called a point of concurrency. So the centroid is a point of concurrency. The incenter is a point of concurrency. The circumcenter is a point of concurrency. And the orthocenter is one. They're just better classified. Like, so you're all students, right? But some of you are sophomores, juniors, seniors, whatever. Okay. Some of you are repeat sophomores, repeat freshmen, right, Lex? Kitty, nobody's a repeat in here. Your leg gone? All right. So orthocenter, where is it showing up here? It's on the inside of the triangle, right? What kind of triangle is that? Here are those angles. In the green here are the angles. Got a lot here. These three are the angles. These three here with these blue circles next to them are the angles being represented there. What kind of triangle is that then? It's acute. So an orthocenter and an acute triangle is on the inside. What happens? Now think about why this is. It's because an altitude is from a point perpendicular to the line containing the opposite side. When I take this point C and put it on top of A, where does the orthocenter go? It's now where? Not the hypotenuse. That point F isn't the orthocenter. The orthocenter is the intersection of your three altitudes.
The vertice of the 90-degree angle?
Absolutely. It's on the right angle now, right? Okay, so the orthocenter is down there at point D. Okay, because the orthocenter is the intersection of altitudes. An altitude is from a vertex perpendicular to the opposite side. It's those purple lines and that black line, right? Those are my altitudes. Okay? The two purple ones, they are what for your right triangle? They are perpendicular, but what do you call them for your right triangle? Those two sides are the blank of your right triangle, the legs. Okay? So when in a right triangle, your altitudes are always your legs. And that's where I think you get in trouble with questions from like 7th grade, 8th grade, 9th grade, because when you're trying to find like area of triangles, the number one type of triangle you were given in those courses was a right triangle. So you just took that to be, so you took this distance here to always be H, and this one to be B. Does that make sense? Okay? And then you get ingrained in that, and then when I give you this triangle here, you're not sure what to use as B and H. Okay? But you would use one of those red distances there as H, and then the side that it's going to as B. Does that make sense? Okay? But you've been trained because of this one special triangle, because it's really easy in that one special triangle to pick off B and H, and it really doesn't matter because B times H is the same thing as H times B. Okay, so you can even let that vertical distance be B and that horizontal distance be H. Or, if you wanted to, you could let this distance be H. Okay? And then the hypotenuse would be B. All right, but that kind of discussion about that formula we'll do a lot more of later on when we specifically talk about area. When my triangle is like this, what kind of triangle is that? It's obtuse, right? Okay. Where is the orthocenter existing for an obtuse one? Oh. It's on the outside, right? Okay. Now, we haven't talked about this, but let's look at this. Let's go back to, I think that's better explained in kind of this picture here, maybe. If I get those to go back to 0, again, remember that this is my desk, right? This purple line is my desk. This point here is floating in the air. All right? If I want to find a line from this vertex up here, or a segment from this vertex up here, that is perpendicular to the opposite side of my triangle, the opposite side of my triangle is going to be, let's see here, do you agree that that little purple section is the opposite side of my triangle? I don't know if that's the best color to use. Can we see that better? Okay. That is the opposite side of my triangle. Are there any segments that go to that opposite side of my triangle that are going to be perpendicular? No. So what we have to do is we take that turquoise segment right there and we extend it. Okay, we extend it so it looks something like that. We extend it that direction, and now is there going to be a line that goes through this point up here perpendicular to that side, or that line? Does that make sense, everybody? Okay. So that would be my altitude, or one of my altitudes. Is that okay with everybody? So when you have an obtuse triangle, you have to extend the segments or the lines that make your obtuse angle, and that's how you're going to find the altitudes. Okay? They exist on the outside. Now, if I were dealing with trying to figure this, if you had that on your desk, and I asked you to find the height of it, why don't you take your tape measure from here straight down to your desk? That make sense? Okay? But again, at the same time, you could maybe do it that way. If I laid that on my desk that way, wouldn't that be one altitude? Okay? Or if I did this, whoa, that's kind of ugly the way I've got that set up, but if we look at that triangle that's moving, wouldn't this out here be another altitude? Okay? Maybe you can see it a little bit better here. If I look, so those three triangles are all the same triangle. They're just rotated and setting on different sides on my desk, so that horizontal line, kind of where if we look at a horizontal line through where my cursor is, that'd be my desk. Okay, you see different altitudes, right? And two of those altitudes exist on the outside of your triangle. Okay, so when you got an obtuse triangle, your altitudes are going to be on the outside. Two of them are. Therefore, your point of intersection is going to be on the outside. Is that all right, everybody? Okay. Just one more thing that we got to kind of keep in mind as we move through to the end of end of the textbook, where we get to chapters 11 and 12 and start dealing with area. If I want to find the area of that blue triangle, those distances, those red distances I just highlighted, those are the H's that you would use in your formulas. You don't use obviously the entire altitude is a ray, right? So a ray does not have a distance, it doesn't have a length because it goes on forever. So when I want H for my formulas in my triangle, I just use those dotted distances, those red dotted distances. There are features of altitudes, guys, that we could talk about. Maybe we will on Monday. Kind of like the centroid being the center of gravity, the end center being equidistant from the sides of a triangle, the circumcenter being equidistant from the vertices of a triangle, that kind of stuff. We'll have a little time on Monday. We'll talk about that with orthocenters. All right, so now this is something, I don't want you to think, well, Mr. Fay just said this statement, so I can just kind of ignore everything that we're doing and just say, I'm never going to use it again, so why even care about it? But I'm going to venture to say that after this section, other than on the end of course exam, it's going to be rare that any of us go through and use the orthocenter, centroid, circumcenter, in-center stuff again. Okay? Now, depending on maybe what field of study you go into in college, or if you're in the military, whatever branch of the military you go into, you start using technology, maybe you use some of those things. I don't know. Okay? But the likelihood of all of us needing to use these points again is very, very, very minuscule. Okay? Other than on the end of course exam. So that's the importance part of it, is that you're going to use it on the end of course exam. However, if I want to find, let's say, the equation of a altitude, so let's say we put 3,1 here, let's put this one out here at 5,2. Let's say I want to find the altitude from B going to that line C. I want to find the equation of that. Okay? Finding the equation of a line, guys, is something that you're going to use outside of this course quite a bit. Okay? You've maybe already experienced this. So this is just going to open your eyes, hopefully, a little bit to maybe some of the purposes of why I teach the way I teach, and make sure that we hit the algebra that I think is important for you to be successful elsewhere. Because right now, talking about these 4 points of concurrency, we're practicing algebra over and over and over again that's very similar. And the algebra might be used in chemistry or in biology or whatever, okay? So you guys have done this before. Let's say I take did anybody do, it's called a Barbie drop last year, and some of the people in the last class talked about this. So with the Barbie drop, you're basically taking a Barbie, making a bungee string or bungee cord out of rubber bands, and you drop it from different heights, right? But you have found some characteristics of that rubber band that allow you to project what maybe how many rubber bands I need to string together to make the bungee cord, right? Okay? So you've done that. But in the process of doing that and trying to decide how many rubber bands to string together, you did some preliminary data, okay? Or if you're in science and you used to do like a lab experiment that says we're going to heat up some water, okay? And we're going to take temperatures of that water for like every minute increment, okay? So let's say that I did that. So at 1 minute, there's the heat of my water, temperature of my water. 2 minutes, there it is. 3 minutes there. 4 minutes. 6 minutes. 5 minutes. And let's say 6 minutes down there. And then somebody else does the exact same lab, and they find that at 1 minute, that was the temperature. 2 minutes, that was the temperature. 3 minutes. 4, 5, and then 6 again. And then somebody else does the lab one more time, and maybe we find maybe points like this. Do you guys know what these points are called collectively in a graph? Starts with an S. When you're just putting point, not connecting them. It's called a scatter plot. You ever heard that before? Oops. Okay, so we got just those data points, right? And this is what you would have done if you did that Barbie bungee drop. Okay, so those of you that experienced that. But then you tried to connect maybe that point and maybe that point. Anybody remember what that blue line was called? Line of best fit. Sometimes maybe you call it a line of regression. Okay, but what that does, we call it best fit because it models the rest of our data, right? There's some points on top of it, there's some points on the bottom of it, and there's some points that are on it, right? And the purpose of that is to say, okay, now we can do what we call interpolation or extrapolation, okay? And basically what it means is I can come up with an equation of that line. You know that point right there. That was a data point that you chose and that you recorded, right? You know that point right there. That was a data point that we chose and we recorded. Can I use those 2 points that are in the form of x, y to find a slope?
Yeah.
Can I use one of them as x1 and y1? So I can find the equation of that blue line, right? That blue line gives me all the infinite number of points that are on that blue line, right? So what interpolation is, means that once I have that equation, I can find data points of things that I did not record that are between maybe 0 and 6.5 seconds. I never recorded what the temperature of that thing was at 2.3 seconds, right? Or sorry, 2.3 minutes. But now I can plug in 2.3 to my equation, and it gives me a good estimation of what that temperature is. Does that make sense? So that interpolation, the prefix is in, right? IN. So we're doing kind of an inside kind of estimate, okay? Extrapolation means, okay, it allows me to predict future temperatures, okay? So I didn't record something past 6, okay? So maybe if I want to find out what the temperature was at 6 minutes and 15 seconds, I can plug that number in to my equation and get a temperature, and I can predict then how that thing is cooling off, right? So you did the same thing with the bungee jump with the Barbie last year if you experienced that. But that process of writing that equation on line, guys, is the exact same thing that we are doing right here, okay? Now, I don't give you enough information to find the slope specifically of that black line. But you know that has 0.31 on it, right? Okay? When I write the equation of a line, I always need two things. I need slope, and I need a point on my line. Well, that point right there is the point on my line. That's my x1, y1, right? Okay? I'm trying to find the equation of the black line. That's my x1, y1. Now, I don't know the slope. How many points do you need to find slope? 2. And because of that line, I don't know 2 points on it, and I don't even want to guess. Okay? Somebody said in the last class, well, you know that point right there. Well, what if the picture just shows that blue thing there? Or what if the directions are just, I give you the order of pairs, I didn't give you a picture, right? You don't want to try to estimate what that point is, even though I'm using GeoGebra here that does a very, very good job of graphing, right? So you only know 3-1. But how does an altitude, by definition, how does an altitude relate to segment AC? It's perpendicular. So that blue line is perpendicular to that red one. Do you know a way to find a slope of that red one? If this is 1, 4, and that's 5, 2, 4 minus 2 is 2. 1 minus 5 is -4. So the slope of the red line is -1/2, right? So now what's the slope of the blue one if they're perpendicular? It's got to be 2. It's the opposite sign reciprocal, right? So m of the blue one is 2. Can I plug that in there? x1 was 3. y1 was 1. We got the equation of that line, right? That's the exact same thing you would have done in science when you're trying to find the line of best fit. You use 2 points on your line somehow to get slope, okay? And this one you don't have 2 points, so you have to use a different technique to find slope, but there's only really 4 ways they can hide the slope to you. One of them is really nice. They can just give it to you. They can say, hey, use a slope 2, okay? The other way is to say the slope is hidden through the use or the knowledge of having 2 ordered pairs on the line they're trying to find the equation for. So you can do y2 minus y1 over x2 minus x1 directly, okay? The third one is to say that they're parallel. If I have 2 lines that are parallel, what's the relationship between their slopes? They're the same, okay? So I can just kind of cut and paste the slope of the line I'm supposed to be parallel to. And if they're perpendicular, we use this property, but they're opposite sign reciprocals, right? But every single time, whether you're in geometry class, your algebra 1, algebra 2, chemistry, physics, calculus, when you're trying to find the equation of a line, you need those 2 things, slope and x1, y1, and you just have to be thoughtful, okay? You got to do a little bit of problem solving to develop and understand, okay, what are my x1s and y1s? What's the point on the line I'm looking for? And through definitions and vocabulary like altitude or median or something like that, what's the relationship between slopes I could use? Okay? Does that make sense? The more you know your vocabulary, the easier it's going to be for you to design a process for finding your equations. All right. I've opened, just recently, reopened 5.4. Okay, shut off at 11 today. But that's open until Monday. You have yesterday's assignment that I sent out to in an email. I want that to make sure you have that completed by Monday. No new homework on top of any of that. But in the next 13 minutes, I want you guys to get on Math Excel. And there's a vocabulary quiz. The first one is about a theorem. And I want you to type in fractions. When it says type in a ratio, type in a fraction. And that will be available here in a moment. Good morning, Dalton. Log in your computer. Good. All right, so the quiz is called Triangle Relationships. It has not taken anybody longer than 10 minutes to complete, so you guys should have ample time. You may start, yes.